Myself, V. Manikanta from ECE branch, C section, bearing roll number 24BQ1A04I5. Today I am going to give seminar on the topic set theory. Set theory consists of two topics. Those are types of sets and operation on sets. First, let us see what is a set. Set can be defined as a collection of elements enclosed within curly brackets. In other words, we can describe this set as a collection of distinct objects or elements. For example, let us take a basket and put some apples in it. We can call the basket as a set because it contains similar elements among it. Types of sets. We can classify sets based on the number of elements present in them and their equality. Finite set. A set containing a finite number of elements is finite set. Empty set come under the category of finite sets. If at all, the finite set is non-empty, but there are called non-empty finite sets. We can say that finite sets, the elements in the finite set can be countable. We can count the values present in a finite set. For example, let us take set A, in which it is the first month in a year. Set A will contain 31 elements. Those 31 elements are the dates. Empty set. There will be no elements in the set. It is represented by the symbol phi or the curly brackets with no values. The other names of empty set are null set or void set. This set does not contain any elements. Infinite set. In contrast to the finite set, as we have seen, the finite set is a set which has values that are countable. In similar way, infinite set has elements which we cannot count. For example, infinite integers. A is an infinite set. Group of integers is an infinite number. Equivalent set. Equivalent set are the sets which have same number of elements present in them. They may not have the same elements as equal sets. For example, if a set A has elements minus 5, 7, 6, and set B has elements 16, 7, 8, these two sets are equivalent in nature, whereas they does not have any same elements, but they have equal number of elements. Universal set. This is the base for all other sets formed. On the context, universal set is decided and it can either be finite or infinite. All the other sets are subsets of universal set. Example, set of natural numbers is an universal set for integers, real numbers, whole numbers, etc. Subset. If let us take two sets A and B. A subset of B if every element in B is also present in A. A can be equal to B. This is formally written as shown. If A contains elements as 2, 4, and B contains elements as 1, 2, 3, 4, 5, 6, 7, 8, then A is a subset of B because A has every element present in B equal set. Two sets are said to be equal if they contain exactly same elements regardless their order. Example, if set A has elements 1, 2, 3 and set B has elements 3, 2, 1, then we can say A equals to B. These two sets are said to be equal because they have same elements regardless they are order. We can say that every equal set is an equivalent set, but every equivalent set may or may not be a equal set, disjoint set. Two sets are said to be disjoint if they have no elements in common. Example, A equals to 1, 2, 3, and B equals to 4, 5, 6. Then A and B are disjoint because A and B does not have any common elements. Now, let us summarize what we have learned. Types of sets. First, let us see an unequal set. Sets do not have all the same elements. We can see the example as set A equals to 1, 2, 3, set B equals A comma B. They don't have equal number of elements or same elements. Power set. This set contains all possible subsets of a given set. Power set of A comma B equals to a null set A, B, and A comma B. Overlapping sets. Sets share at least one common element. Set A is equals to 1, 2, 3, and set B equals to 2, 4, 5. They have at least one element in common, that is 2. Disjoint sets, as we have seen, sets that have no elements in common. Subset, a set where all elements are also members of another set. Empty set, set containing no elements whatsoever. Null set. It is also known as void set. Singleton set. Set contain exactly one element. It has only one element. Every empty set is a singleton set. Finite set. Set with a limited countable number of elements. Infinite set. Set with an uncountable number of elements like natural numbers. Those are infinite in nature. We cannot count those. Equivalent sets. Sets that have same number of elements and their elements can be paired one to one. Assume set A has elements 1, 2, 3. Set B has elements A, B, C. One can be mapped with A, B, C. Just one mapping. Equal set. Sets that have the same elements. Like set A has 1, 2. Set B has 1, 2. We can say those two are equal sets because they have same elements. Let's move on to the next topic, operation on sets. Operation on sets. Consider two different sets A and B. There are several options that are frequently used. Operation, intersection operation, complement operation, difference operation. Union operation. Union is given by symbol U. Set A union B denotes the union between the sets A and B. Is read as A union B or union of A and B. Is defined as the set that contains elements belonging to either of the sets. We can say that it gives the total number of elements present in both the sets. As for example, we can see let the elements present in set A be 1, 2, 3, and the elements present in set B be 4, 5, 6. A union B gives the total number of elements. Those are 1, 2, 3, 4, 5, 6. It gives all the elements present in A and B and removes the common ones and which are repeated twice or thrice. Intersection. Intersection operation is represented by the symbol inverted U. Set A intersection B is read as A intersection B or intersection of A and B. A intersection B is defined in general as a set that contains all the elements that belong to both A and B. We can say that it gives the common elements present in both A and B. For example, let us take a set of elements in the set A. Those are 1, 2, 3, and the elements present in set B are 2, 5, and 9. And A intersection B gives 2 because A and B have only the number 2 in common. If there are no elements present common between A and B, we can say that A intersection B is 5 or a null set. There is no common elements present between A and B. Complement or difference between sets. The relative complement or set difference of two sets A and B is the set containing all the elements that are in A but not in B. Formally, it is written as A minus B, or it can also be written as B minus A. As we can see below in the figure, the difference shows it removes the elements present in B from A, and similarly, it removes the elements present in A from B. For suppose A has elements as 1, 2, 3, 4. B has elements as 2 and 4. If we do A minus B, it removes the elements present in B from A. That implies A minus B equals 1 and 3. It removes the elements from A, that is 2 comma 4, which are present in B. And the complement, it is U minus A. It is the all the elements which are apart from the given set, and U is a universal set. Thank you.